So the presentation will be quite brief. I will walk through some key concepts in ecological psychology, in evolutionary biology, and in the reinforcement learning. Most of the things which I will be talking about have been already said during the conference, so concepts like affordances or niche. However, I will try to introduce you to a new dimension, how affordances could be characterized. And I hope that you will understand this sentence more deeply after we will go back to this start screen. So relations are distributed along the exploration-exploitation spectrum. By relations, you can understand for now affordances, but we will dig deeper into the meaning of the relations. What do I mean by relations? In a moment. Affordances. What the affordances are? We have to start that an environment is unique for a given organism. Every organism, depending on its development on the ontogenic and phylogenic level, has a unique environment to some extent. The greater the development, the more unique an environment is. And affordances are dynamic relations between an organism and its environment. So this is an idea which goes back obviously to Gibson, Chemero, Bruineberg, people who were working in ecological psychology or in cognitive sciences, broadly understood. The dynamism of the relation points to this temporal aspect that an environment is ever changing. So the relation between an organism changes, between an organism and its environment changes as well, and interactions leads to new states, that perceiving a state and following a state leads to new perceptual states. And it has to be noticed that some relations are more relevant than others. So now we switch that from we have this concept of relations, that this is some sort of connection, interaction between an organism and environment. And these relations, interactions, some of them are more relevant than others, given the, for example, physiological state. Some relations are more desirable to follow than others. If one is thirsty or hungry, then one will look for fulfilling its desires to drink or eat. And the concept from evolutionary biology that organisms construct niches. So we can understand that parts of the environment, parts of the variable relations, are harvested, utilized by an organisms into niches. The second topic is the reinforcement learning. So what the reinforcement learning is. Key concepts in the reinforcement learning is that we have an agent which travels through possible states within its environment. It explores these states and looks for some kind of rewards. Usually an agent and all these states and environment is an artificial agent and an artificial environment, at least in the computational discipline, it began this way. But surprisingly, this framework has been applied to cognitive neuroscience, and we have experimental evidence that some sort of tasks, for example, dual step tasks or multi-step tasks, reflect the kind of environment in which reinforcement learning can be applied, and behavior of animal model or human participants reflected in certain brain activity is consistent with the theoretical aspects of the presented in the reinforcement learning framework. So an agent could be an artificial agent, but simultaneously it could be an actual biological organism. And this agent, when exploring, familiarizing itself with the environment, it has a dilemma, whether to explore or to exploit. By exploration, I mean that an organism can perform new decisions, choose new pathways, explore new directions in its environment to build some sort of map or causal link between a current state and possible states toward which the given action will lead. On the other hand, an agent can exploit old decisions, virtually repeating past decisions with idea that the same outcomes which have been reached in the past will be reached again with the same decisions. The theoretical aspects in the reinforcement learning differentiates two controllers, model-based and model-free controller. And this distinction basically goes back to Tolman cognitive maps and stimulus response accounts. It goes back to Larry Square studies on memory systems, that we have some kind of hippocampal dependent system which will be flexible, expensive, slow, relational, declarative, representative, and different memory system which will be automatic, habitual, like related to activity of the dorsolateral striatum, for example. And the model-based and model-free controllers reflect this broader division of the memory, which is visible in cognitive science research, broadly speaking. And the important thing here is to note that the controllers, at least in the reinforcement learning account, works simultaneously and independently to guide decision-making and action. So both controllers collect, gather sensory information and makes their own predictions, and the balance of activity between these two controllers dictates what behavior is performed by a given agent. And the third slide, relations are distributed along the exploration-exploitation spectrum. So we can recall that's the same sentence which was on the first slide. An organism acts in its environment by following dynamic relations. So we've already said that, there's nothing much to add here. Relations underlie a spectrum from an environment which would denote all possible for exploration affordances. So we have all of these decisions or actions or relations or interactions which an agent can undergo within its environment, and some of these relations are not explored, have not been undertaken yet. So has to be explored in order to get familiar with the causal chain that given a relation leads to. And the other end of this spectrum would be a niche, which would be repeatedly exploited, signifiers. And I use signifier term here as kind of opposing to affordances. The term comes from Norman paper, or actually a book. And if we think about affordances, like if I take phone, here I have a phone, okay. So if I take a phone, I will have a whole surface of the phone will have an affordance of tapping, so I can tap anywhere. But if I want to perform a certain action with certain outcome, I have to tap in a specific parts of the screen. So these specific parts would signify from this external point of view a proper action to fulfill in order to meet my ends. So this would be a dimension of relations from explorative affordances to exploitative signifiers. A picture of supposedly how I imagine this kind of dimension. So we have a cone of this blob, which would denote signifiers, which are automatically followed by an acting organism. And the periphery of the blob would denote affordances, which can be explored and incorporated into a niche, but this is a matter of future. An organism has to actually explore these affordances in order to be familiar with them and introduce it, incorporate it into a niche. And that's basically most of the talk. So once again, relations are distributed along the exploration-exploitation spectrum. I hope that you understand this phrase better now. This is a part of an article that I'm currently working on, and hopefully it will be submitted soon. So I will greatly appreciate your feedback on that matter, and also feedback on the graphical representation, whether maybe you have some ideas how to improve it, or maybe it sparked your curiosity or interest anyhow. Thank you very much.